Now we're going to continue and take a look at the example problems that I'd like to work with you in Lesson 3.2 on polynomial functions. Let's look at number 1. It says determine whether the function is a polynomial function. If it is, identify its degree. What you need to do is take a look at the x's and their powers. If the powers are non-negative integers, in other words, positive integers, no x's in the denominator, no x's underneath square roots, then you are dealing with a polynomial function. So this is a polynomial function, and its degree is, well, it's the highest power. So this is, the degree of the polynomial is 5. Number 2, 7x to the 7th negative pi x to the 4th plus 1/2 x squared. Just look at the x's. Each one of those has a non-negative integer power, so it is a polynomial. I know you might be looking at that pi, but the only restriction is that the coefficients need to be real, and pi is a real number. What's the degree? Look at the powers, 2, 4, and 7. The degree is the highest power, which is 7. Let's look at number 3. Is it a polynomial function? 4x to the 4th plus 6x to the 3rd plus 4 over x. When you have an x in the denominator, that means that if it were written outside the denominator, it would have a negative exponent. You cannot have x's in the denominator and it be a polynomial function, so this is not a polynomial function. Number 4, it says determine if it is a polynomial function. X to the 1/3, immediately the powers must be non-negative integers. 0, 1, 2, 3, 4, and so on. That is 1/3. That means the cube root of x, and that violates the definition of a polynomial function, so this is not one either. X is in the denominator, x's underneath a radical sign are not polynomial functions. Now, let's take a look at number 5. It's going to ask us a variety of questions, and we'll use the information that we already know. They're going to ask us all of these questions, and then we're going to graph it. Whoops, sorry. Get back to it. All right. We have f of x is equal to x to the 3rd plus 3x squared minus x minus 3. Yes, it is a polynomial function. So let's just identify a couple of things. First, the leading coefficient test. The leading coefficient test. And it has to do with the leading coefficient, which would be the coefficient of the highest powered term. In this case, a is 1. Which means it's positive. A is greater than 0. The degree is 3. Now that is an odd number. When the degree is odd, it goes down on the left and up on the right. I hope that you have written down, what's not on this screen, from the previous video, the summary of this. So, when it is 3rd degree, it's going to be down on the left, up on the right, as long as the leading coefficient is positive. So let's see which one that is. Falls to the left and rises to the right. Now it asks me to find the x-intercepts. So I'm going to pull my graphing calculator up and find them. So let me clear this. Go to y equals. Clear that, and I'm going to type in the function. It is variable x raised to the 3rd power, get out of there with the right arrow, plus 3x squared minus x minus 3. Now I could actually, they created one that I could have factored, but I didn't. So I'm going to do a zoom 6. And let's see if we see what we thought we would. Is it going down on the left? Is it going up on the right? And does it wiggle in between? Yes. The x-intercepts, which are the zeros, there's one there, there's one there, and there's one there. So if I want to, I could drag this over, and now let me push this up a little bit. Well, I thought I could. Maybe I can't. Okay. Back to the grapher. I'm also going to have a y equals 0 because I'm finding the zeros. Mine's in color so you can see that. And I will do second, calc, intersect. I like to go in order from left to right. So I'm going to try to get the coordinates of this one. Enter, enter, enter. So the first one occurs at -3. I'll write that down in a minute. Then second, calc, intersect again. Head to the second one. Enter, enter, enter. -1. Then a third time, second, calc, intersect. Head to the third one. Enter, enter, enter. And there it is. We have the third one, which is 1. The x-intercepts are, it says type an integer or a decimal, use a comma to separate. So it is -3, comma, -1, and 1. We found them left to right. Okay. It says at which x-intercept, and I've got a picture of it over here. At which x-intercept does the graph cross the x-axis? Well, it crossed at -3, it crossed at -1, and it crossed at 1. So it crossed at -3, it crossed at -1, and it crossed at +1. At which x-intercepts does the graph touch and turn around? Now let me give you an example of what I'm even talking about. If my graph came down, touched there, and bounced away, that's what it's talking about. And I don't have that scenario. So I will click right here. Now, these occur when the roots, the zeros, etc., are even multiplicity. All right, this was even multiplicity, and I did not have any even multiplicity. This is what happens with odd multiplicity. You couldn't really see this because we didn't look at it in factored form. If we had, we would have had f of x is x plus 3 times x plus 1 times x minus 1. I just created this by changing them from 0 format to factored format, which did change their signs. Each one of these has multiplicity 1, so they all cross through. Okay, going on. The y-intercept, I can look at it and I can go to table, second, table. I can type in x is 0, but it's already there. The y-intercept is -3. Now it says determine whether the graph has y-axis symmetry, origin symmetry, or neither. And we can just take a look at the graph, and it does not match across the y-axis, and it does not match across the origin either. So this is neither. And now it wants me to use the graphing tool to do this. So I will I will go to my math lab in just a minute and do a similar question, or maybe I'll do that on number 6. But for this one, I will choose what the behavior looks like, and there will be a tool that will kind of look like this. And my x-intercepts were at -3 and -1, and the y-intercept was at -3, and then I had an additional, x-intercept here. So if I were just graphing this on a piece of paper, it comes up, it hits that, it comes down here, and it turns around, and it looks like that. I will demonstrate in my math lab in just a minute how this works in math lab. All right, I decided to go ahead and go straight into math lab, and this is a slightly different problem, but I can go through the steps when we're ready to show you how to do the graphs. First of all, this is a third degree, so it's an odd degree positive leading coefficient. It falls on the left and rises on the right, so that's okay. X-intercepts, I did these off screen, and these are, let me get myself a keyboard so I can type them. They are, there's one at -1, comma, +1, comma, +2. I did that off screen. All right, this one looks very, very much like the one that we were looking at, and all of these cross the x-axis, so I will list them all again. -1, comma, +1, comma, 2. All right. Which ones touch and turn away? There are not any, so it is that one. That's good. The y-intercept. The y-intercept of this is the final value up here. I could get it from the graph. It's 2. And I just wanted to do those so that I could ultimately get over here. There is no symmetry. And now I'm going to come to the graph. I want to click to enlarge it. All right, what is the shape? This is my shape, and I get to do a 4-point cubic tool. All right, the 4 points, I believe they will be the 3 x-intercepts and the y-intercept. So it was -1, +1, +2, and also +2 there. Okay, so I did my intercepts and I did the y-intercept. Save it, check it, and we correct. Okay, so that's how you will graph these. I like to graph the x-intercepts first after I've chosen the right shape, and then the y-intercept. So I'm going to leave that. Go back to OneNote. Okay. All right, moving on to number 6 now. We have x to the third minus 2x squared minus x minus 1 or is this the one? I guess we haven't done it. It's very similar to number 5, but I will take a look at this. I see that it is cubic. I see that that's third degree. Leading coefficient is 1. Since A is greater than 0, I know, and it's odd degreed, I know that the behaviors are down, up. All right, so let's take a look at our grapher. This is y equals, I have another x to the third, so I can just leave that. And I have subtract 2x squared, subtract x, and plus 2. So I'll make my adjustments. Take a look at my graph. Is the behavior correct? All right, it is down on the left and it is up on the right. I'm going to grab the picture, put it right there so I don't always have to be looking at the grapher, and it falls to the left and rises to the right. So here it is. The x-intercepts, I can do second calc intersect with the y equals 0, but I'm pretty sure that this is kind of like the one that I did in my math lab. The the x-intercepts occur at -1, +1, and 2. They are all passing through. So all of them that pass through, they say cross, -1, 1, and 2. There are none that touch and turn around. The y-intercept, when this is in that nice general form, the y-intercept is the constant, although you can do second table. So the y-intercept is 2. And taking a look at that again, there does not appear to be any symmetry. The graph, I will use the graph tool that looks a little bit like this, and I will probably get to do 4 points, and they were -1, +1, +2, with an y-intercept of 2. Yes, perhaps this is exactly the same question, but that's what it will look like. All right, let's look at number 7. All right, on this one, this is 4th degree, which is an even degree. The leading coefficient is a +1, that's greater than 0. That means that the end behaviors will be up and up. So rises left, and where is it? Rises left and rises right. So it's this one. The x-intercepts, okay, let's go back to the grapher. Clear that out, and I have x raised to the 4th power. Use your right arrow to get out of that. Minus, for some reason they went ahead and gave us a 1. We didn't need that 1. X squared. All right, let's take a look at this graph. All right. It is difficult to see what's happening right here. So I'm going to change my window, and in the x's I'm going to only go from -5 to +5, and I'm going to do the same thing in the y's, -5 to +5. Let's see if I can see better. All right, I can see it, and if you want to see one more thing, I will show you in the window with my y's. I'm going to just go from -1 to +1 so that you can see it even better. Okay, so this was quite a distorted window. If you wanted to play with it, the x's are going from -5 to 5, but the y's are only going -1 to 1 so that I could see. You can do second calc intersect, but you're going to get an x-intercept at -1, at 0, and at +1. Whoops. And I got multiple copies of it. Let's see. I don't. Okay, I just have one copy now. I will look at that. There we go. At 2. All right, the x-intercepts I have at -1, 0, and +1. You don't have to put them in a certain order, but I try to list mine left to right. All right, crossing the x-axis. Now it only crosses the x-axis at -1 and +1. At 0, it comes up, touches at 0, and bounces away. So where it says touches and turns around, that happens at 0. That is multiplicity 2. And f of 0, which is the same as the y-intercept, is 0. Now if you look at this, can you see that it is symmetrical with respect to this y-axis? It is an even function. It has y-axis symmetry. Also, up here, can you see that it is an even function? All right. Now, determine which of these is the right graph, and they are very tiny. You could enlarge them, and you would want to enlarge them, but it turns out that this is the right one. You just can't tell from my video picture. All right, so let's go on to number 8. I think we will do number 8, and then perhaps we will pause again so that this is not such a long video. All right, this is a 4th degree function. So it is 4th degree, that's even. That means it's either up, up, or down, down. Because the leading coefficient is less than 0, it's a negative, it's going to be down, down. So falls left, no, it's choice A. Let's take a look at the grapher. And it is, I'm going to do second insert negative sign. I could have just retyped it, but I didn't. And pass through all of those to plus 16x squared. So I've got a 1. I'm going to move here and do second insert and try to get the 6 in there. I did. All right, so negative x to the 4th plus 16x squared. And I'm going to do a zoom 6. Waiting on the graph. All right, I know that it is supposed to be down, down, which means that there's some information up here at the top, some relative or absolute maxes. So I'm going to not hit mode. I don't know why I did that. I'll go back to, I'll go to something. How about window? I need Y max to be extended. Sorry about all that jumping around on the calculator. Let's do 50. I don't know that that's good, but let's look at it. It's going to go up, hit a max. Uh-oh. Okay, I didn't see enough. So I will go to Window again, and I will change it. This may be excessive, but I'm going to change it to 100. All right, this is the inverted W, and I will, as soon as that finishes graphing, I will take it and put it here. All right. The x-intercepts, yes, I could do second calc intersect and get them. I will tell you that they occur at -4, 0, and +4. It wants to know about the ones that cross the x-axis. It crosses at -4 and +4, and then it touches and turns around at 0. So although we didn't see this because I used the grapher, I want you to know that this function looks like f of x is equal to, it would have x squared times x plus 4 times x minus 4. Those would be the factors. This one would give you x equals 0, but it is multiplicity 2. That's why it touches. This one would give you x is -4. Multiplicity 1 passes through. This one would give you x equals 4. Single multiplicity passes through. But this exponent of 2, if we had done this, if we could have factored it, we would have gotten that x equals 0 is the 0, but it is twice, and that changes the behavior to touch and turn away. The y-intercept is 0 again. This is another even function. We're supposed to determine the graph, and I think we can see pretty easily that it is this one. All right, I'm going to pause this video, and then we will continue because there are quite a few more questions, but we will go ahead and pause here so that the one in my math lab will not, in YouTube will not be too long.